Namaskar. So, welcome to the third week of our course on basic electrical circuits. So, today we will start the discussion on network theorems, and in this particular lecture we will discuss about the linearity properties and the source transformation. So, let us start the topic on linearity property. So, what is linearity? Linearity is the property of an element describing a linear relationship between cause and effect. So, cause can be an input, like if you provide voltage or current input which causes the element to either absorb or dissipate the energy. So, voltage or current source is causing some phenomena inside the circuit, and as a result, that is effect, you will get some output voltage or current a particular element. So, the cause and effect will be having the relationship which is linear in this case. Now, although the property applies to many circuit elements, but in this particular lecture we will limit our applicability to resistors only, because it is easier for us to understand the properties in terms of resistors, and then we can scale it up for other linear elements like inductors and capacitors. Now, the linearity property is a combination of both homogeneity and additivity. Now, what is homogeneity? Homogeneity means the property which requires that if the input, or you can say that excitation of the network is multiplied by a constant, then the output is also multiplied by the same constant. That means that your excitation and the response will have homogeneity, means if you scale up a particular voltage input by say constant k, so output effect, that may be the voltage across a particular element or current flowing through that particular element, will also be multiplied by the same constant k. So, now let us see how we will define it. Let us take the example for one resistor. It is following Ohm's law. So, as per Ohm's law, what you can write for voltage? Voltage would be current I and multiplied by resistance R. Now, if it is following the homogeneity property, it means that if current is increased by constant k, then voltage will also be increased by constant k. So, in that way what you can write? You can write k into IR is nothing but k into V. Now, after homogeneity, if you are asked to find what is the additivity property, so additivity property will say that the response to a sum of inputs is the sum of responses to each input applied separately. Now, suppose if in the circuit you have two voltage sources, that maybe you can say V1 and V2, which are applied across a resistor R. So, V1 and V2 we both are applying separately to a resistor R. Let us take one DC source and we have resistor R, we have another DC source, and suppose it is connected through some switch. So, you have switch connected either for voltage, that is V1, or to voltage V2. So, now when it is connected to V1, then you will have some current I1 flowing through it, and the V1 will be across it, and you will get I1 into R. After getting this value, if you switch over from point 1 to point 2, it means that now it is connected to voltage V2. So, it will become say this current is now I2. So, V2 would be I2 into R. Now, when you apply both V1 and V2 at the same time, suppose if you are current should be sum of individual currents provided by individual voltages, and it will follow this equation like V1 plus V2 would be equal to I1R plus I2R. So, this is basically called as a additivity property, means you can add the responses of the individual voltage or current sources and get the final response that may be in the form of current or voltage. Now, why we say the resistor is a linear element? Why? Because the voltage and current relationship of the resistor satisfy both the homogeneity and additivity properties. So, what we can say in general, the circuit is linear if it is both additive and homogeneous. Now, what is a linear circuit? Linear circuit is the circuit which contains only linear elements, linear dependent sources and independent sources. So, in the linear circuit, the output is linearly related to its input. So, now although the circuit may be linear, but its input output relationship may become non-linear. So, can we apply the homogeneity and additivity in that case? So, if suppose your input is voltage and output is power across a resistor, so what relationship they will follow? They will follow relationship like P is nothing but I square R. So, now if you see this particular equation, the relationship between voltage and power is not linear. So, in that case you cannot apply the homogeneity and additivity property for getting the power across the resistor, because these are not linearly related. So, that is why whatever the theorems we will cover in this particular module will not be applicable to power, because the relationship between input and output is not linear. Now, let us take one example to better understand the linearity property. Let us consider one linear circuit shown in the figure below. Here we have a linear circuit which is inside this particular box. We do not know what is the configuration of that circuit. We know that some input is being applied, that is Vs, and we are finding out what is the value of current flowing through the resistor R. Now, the assumption is that there is no independent source inside the linear circuit. So, the source is only Vs and the output which we want to measure is current flowing through resistor R. Now, if current through the load R is the output, and in one case when you apply Vs equal to 10 volt, we get current as 2 ampere. So, suppose you are doing one experiment where you do not know what is inside, but you are applying one voltage source across its input terminals and connecting a load R across its output terminal, and you are measuring current I. So, you can say that if you have added one ammeter here and you are measuring the value of current through this ammeter. Now, if you have applied 10 volt to the input of a linear circuit and you got current I as 2 ampere. So, suppose if you are asked to find out the value of current I when voltage Vs is 1 volt, and you know that this is a linear circuit, without doing the experiment you can straight away say that current flowing through that resistor would be 0.2 ampere when voltage source of 1 volt is applied across the input terminals. Similarly, if you want to get current as 1 ampere through the resistor, what would be the value of the voltage input? The voltage input value would be 5 volt, because this is a linear circuit and it will follow the homogeneity property, which says that if you scale up or scale down through some parameter k, the input output relationship should not change. So, if input is increased or decreased by constant k, then output will also be increased or decreased by the same constant k. Now, let us take one example to understand the properties which we discussed, like linearity and the additivity and homogeneity. Suppose the voltage source Vs is 12 volt in this circuit, and we have to find out the value of current I naught flowing through 4 ohm resistance when voltage is 12 volt and when voltage is 24 volt. So, this would be the case of homogeneity. What we have to do, as we discussed in last week, we did mesh analysis to solve these kind of circuits. So, here we will apply mesh analysis again and try to find out the current value I naught in first case, that is when Vs is equal to 12 volt. So, if you apply KVL to the two loops, that is suppose if you take mesh I1 and I2, mesh currents I1 and I2. So, for this particular mesh, you can write the mesh equation like 12 I1 minus 4 I2 plus Vs is equal to 0, because there are total 3 resistances, the total sum of those resistances is 12. So, it will be 12 I1 minus 4 I2, because I2 is flowing in opposite direction of I1. So, it will be minus 4 I2 and then plus Vs equal to 0. So, this you will get from mesh 1. From second mesh, similarly you can get the value like minus 4 I1, because I1 and I2 are in opposite direction, plus 16 I2, total resistance in this particular mesh is 16 ohm. So, plus 16 I2 minus 3 Vx, because it is going from minus to plus the current I2. So, it will become minus 3 Vs, and similarly minus Vs, because it is flowing from minus to plus. So, you can simply write the equation for second mesh also. Now, if you see what is the value of Vx, Vx would be 2 times of I1. So, the equation can be written as what? You can simplify that minus 10 I1 plus 16 I2 minus Vs is equal to 0. This is in this case, right, and you can use the both of the equations and solve it. You will get I2 is equal to Vs by 76, and the case one, when you take Vs is equal to 12 volt, you will get I naught, that is nothing but I2 in this case, because I naught is nothing but I2. In that case, the value of I2 would be 12 by 76 ampere in case of I naught. Now, you need not to calculate again complete circuit equation for Vs is equal to 24, because you know that this particular circuit is a linear circuit. So, what you will do? You will simply use the homogeneity property, and you can say that the I naught in that case when Vs is 24 volt would be 24 by 76 ampere. So, it means that when source value is doubled, I naught value will also be doubled because of homogeneity property. Now, let us talk about one important theorem called superposition theorem. Now, if a circuit has 2 or more independent sources, the one way to determine the value of a specific variable, that is maybe voltage or current, is to use nodal or mesh analysis, which we discussed in the previous week. Now, in another way to determine the contribution of each independent source to the variable separately, and then you add them up to get the final variable value. So, in this way, when you determine the contribution of each independent source separately and then adding up is called as a superposition theorem. So, what you do in case of superposition theorem? In superposition theorem, the voltage across an element is the algebraic sum of voltages across that element due to each independent source acting alone. So, this will give you a complete property of a superposition theorem, where if you have multiple voltage sources or multiple current sources in the network, you have to take one source at a time and find the voltage or voltage across or current through an element of your interest, means the given element property which you want to find out, and then when you get the variable value independently for each and individual voltage or current source, you will add them up and get the final value of the variable, that may be the voltage or current. Why? Because the superposition is following the linearity property. So, the homogeneity and additivity both would be applicable when you have to use superposition theorem to solve the circuit. Now, this principle of superposition theorem helps us to analyze a linear circuit with more than one independent source by calculating the contribution of each independent source separately. Now, before applying this superposition theorem, we have to keep two things in mind, that when you try to solve the circuit, you will consider only one independent source at a time, while the other independent sources are turned off. So, turned off means what? In the case of voltage source, it will be short circuited, and in case of current source, it will be open circuited. So, if you have multiple voltage and current sources in the network, you will take one source at a time, and other sources would be either short circuited if they are voltage sources, and the current sources would be open circuited. Now, second important thing is that you cannot do that particular, you cannot apply that particular assumption in case of dependent voltage or current sources, and you have to keep them with the circuit and solve them as you have solved for other circuits, like using nodal analysis or mesh analysis. So, dependent source, maybe voltage or current source, should be left intact in the circuit. So, in summary, what you can say for applying the superposition theorem, you will first turn off all the independent sources except one, find the output, that may be the voltage or current due to that active source using any network analysis technique, that can be either simply Kirchhoff voltage or current law, or maybe the nodal or mesh analysis. Now, you will repeat step 1 and 2 for both of the for other independent sources. So, these two steps would be repeated for other independent sources taken one at a time. Then find the total contribution by adding them algebraically, so that you get the contribution of all the independent sources. So, these 4 steps are utilized to apply the superposition theorem and finding out the circuit variables. Now, one major disadvantage you will see when you apply superposition theorem, that is that you need to have more work when you are using superposition. The reason is simple, because when you apply superposition theorem, you have to take one source at a time. So, it means that the same circuit you have to analyze multiplied by number of independent sources in the network. Suppose if there are 3 independent sources, that means that you have to analyze 3 circuits and after that you have to combine to get the final output. So, it means that the same circuit you have to analyze 3 times by making them simpler. So, this will be giving you more work to analyze the circuit. But the important thing is that it helps us to reduce very complex circuit to very simple circuit, because you are replacing the voltage source by short circuit and current source by open circuit. So, using superposition theorem, although you are analyzing multiple circuits by taking one voltage source or one current source on at a time, but eventually you may get the solution very early, because the circuits are now simpler as compared to having the multiple sources connected and you are analyzing that circuit. And superposition theorem is based on linearity. So, it is easier to analyze and then add the responses individually to get the final outcome. Now, that we have discussed earlier that the relationship between voltage and power and current and power is non-linear. So, you cannot apply superposition theorem to find out the value of power. Why? Because power absorbed by resistor depend on square of the voltage and current, which is non-linear relationship between voltage and current. Now, if you need to find out the value of power, what you can do? You can either find the value of current or voltage with the help of superposition theorem, and then finally calculate the value of power after getting the value of current and voltage. Now, let us take one example so that you can understand the superposition theorem more clearly. Now, if there are two sources, if you see in this particular circuit you have two sources, one is voltage source, another is current source. Now, you need to find out the voltage across 4 ohm resistor. So, you can say that you are dividing the circuit in two parts, you are taking one source at a time. So, first you will take voltage source and second you will take as current source and analyze the circuit. So, suppose when you take voltage source first and analyze the circuit, you have got voltage across 4 ohm resistor as V1, and when you apply current source in the circuit, you get voltage across resistor as V2. Since it is a linear circuit, the final voltage across resistor would be V1 plus V2. So, let us take one source at a time. Suppose if you take voltage source first, then what you will do? You will make current source as a open circuit. So, the updated circuit which you will see here would be like this, where you will have 6 volt, and then you need to find out the value of voltage across 4 ohm resistor. So, this will be a simpler circuit. So, you have to just apply Kirchhoff voltage law and find out the value of voltage V1, which comes out to be 2 volt in this case. Now, to obtain V2, what you will do? You have to simply short circuit the voltage source and apply the current source. So, in that case what will happen? You have to use current division at this particular node. You will get the value of current flowing through 4 ohm resistor, that is nothing but 2 ampere. So, in that case voltage V2 you will get as 8 volt, and finally using superposition theorem, what you can say, the total voltage when you have this particular circuit across the 4 ohm resistance would be 10 volt. Now, let us take slightly complex problem where you have one dependent voltage source in the circuit. So, now you have to apply the superposition theorem. Here you will see that you have one current source, one voltage source, and your objective is to find out the value of current I naught which is flowing through 5 ohm resistance. So you divide current I naught as I naught dash and I naught double dash. I naught dash is contribution due to 4 ampere current source, and I naught double dash is the contribution due to 20 volt voltage source. Now to obtain first I naught dash, what we have to do? We have to short circuit the 20 volt voltage source. So we will get this circuit where we have short circuited the voltage source. Now we cannot change, or we cannot short circuit or open circuit the dependent sources. So in this case this is dependent voltage source, so we keep intact with the circuit. The value of this voltage source will be 5 I naught dash, because right now I naught dash is flowing in this particular circuit which we are analyzing while short circuiting the voltage source. So now what we have to do? We have to apply mesh analysis to obtain the value of I naught dash. So we see there are 3 loops. Now for each loop, if we apply the Kirchhoff law, then for I1 the current would be 4 ampere, which is straight away you can see from the figure. For loop 2, if you apply Kirchhoff voltage law, you will get minus 3 of I1 plus 6 of I2, because there are 3 resistances of total 6 ohm value, minus of I3 because I2 and I3 are in opposite direction, minus 5 I naught dash. So this is the value of dependent voltage source. Since you are going from minus to plus, then it will become minus 5 I naught dash and equal to 0. For loop 3, if you see, you can write the mesh equation using KVL, that is minus 5 I1 minus I2 plus 10 I3 plus 5 I naught dash. So here you are going from plus to minus, so it is 5 I naught dash and equal to 0. Now since it is a dependent source, loop equation alone is not able to solve the circuit. We have to take one node and apply KCL also to find out the current relationships. So if you put KCL at node 0, I3 would be nothing but I1 minus I naught dash, or you can say I1 is nothing but I naught dash plus I3. So when you simplify, you will get I3 is nothing but I1 minus I naught dash. I1 we know because we just found that I1 is equal to 4. So this I3 will become 4 minus I naught dash. Now this value you will put in this equation as well as in this equation, and so you will get 2 equations which are in terms of I2 and I naught dash. So if you simplify, you will get value of I naught dash as 52 by 17 ampere. Now to obtain I naught double dash, that is the contribution of voltage source, what you will do? In this case, your current through 5 ohm resistance is I naught double dash. So your dependent voltage source value will become now 5 I naught double dash. Now if you write again the mesh equation for both of the meshes which are there in the circuit, while your current source is open circuit, for loop 4 you will write the equation as 6 I4 minus I5 minus 5 I naught double dash equal to 0. Similarly for loop 5 you will write the mesh equation as minus of I4 plus 10 of I5 minus 20 plus 5 I naught double dash. So why minus of I4? Because current flowing through 1 ohm is, for I5 it is in this direction and I4 it is in opposite direction. So minus I4 would be because of this 1 ohm resistance, 10 I5 because there are 3 resistances of total value of 10 ohm, minus 20 for this voltage source, and plus 5 for plus 5 I naught double dash for this dependent voltage source. Now I naught double dash is nothing but minus of I 5, which you can see from here, because I 5 is flowing in opposite of I naught double dash. So, instead of I 5 we can write minus I naught double dash in these equations. So, when we put the value of I 5, you will get these two equations, and when you will solve, you will get I naught double dash as minus 60 by 70 ampere. You just add the value, you will get final value of I naught, that is minus of 0.4076 ampere. So, with this we close our 2 days session. Next session we will talk about few other theorems. Thank you.